I'm going to start the recording, and it will take a couple of seconds. So once again, hello, dear colleagues. I welcome you at the webinar of the Virtual Medical Consilium on Tuberculosis, which is the initiative of the WHO Euro. My name is Gulmira Kalmambetova. I am the Consilium coordinator. And before I start our webinar, I would like to remind you that one of the directions of our Virtual Medical Consilium is, in addition to those consultations, counseling on some complex cases of TB, including drug-resistant tuberculosis. And should you have any questions and require any technical advice of the international consultants, please feel free to contact us by email. We can offer our consultations both in Russian and in English. The information about the methods of contacting us you can find in chat. Without any further ado, we start our webinar. And today we'll be talking about updated WHO recommendations on TB diagnosis. They were issued in March. And we decided to follow on these recommendations. Without any further ado, I would like to give the floor for the welcoming remarks to the Regional Advisor on Tuberculosis and Drug-Resistant Tuberculosis at the WHO Euro, our dear Askar Yedilbayev. Thank you very much, Elmira, for your kind words. I would like to welcome you on behalf of the WHO Euro. I welcome you at the 27th webinar of the Virtual Medical Consilium, during which we will be discussing the topic of the updated WHO recommendations. I welcome all the participants who found time to join us. I would like to wish all of you to have a very productive webinar. I kindly ask you to write down your questions in chat and have a good work at the webinar. Thank you very much, Askar. Once again, I would like to remind you that we provide these webinars both in English and in Russian. You can choose the preferred language for you, and you can also choose the slides, whether in English or Russian. And now, it is my pleasure to give the floor to our dear colleague, Alexei Korobitsyn, who is the technical officer of the WHO headquarters, who will tell us about the new WHO guidelines related to the new generation sequencing. Please, the floor is yours, Alexei. Thank you, Elmira. My name is Alexei Korobitsyn. As Elmira has already introduced me, I'm a staff member of the Global TB Control Program. And I will make my presentation in English, but you can ask questions in Russian, and I can answer your questions in both languages if needed. Thank you very much for your attention and for your time.
This slide presents pipeline of WHO guidelines, starting from 2010, when for the first time the expert MTBRIF molecular test was diagnosed. Was recommended for diagnosis of tuberculosis, and further on there were updates almost every year, and currently the recent update was made last year in 2023, Unfortunately, it's not moving. Excuse me, I need to share again. I think
we see the screen. Everything is working, Alexei.
It's working, but in my screen it is not working.
You see the Russian slide that it was presenting in the version to relaunch it.
Sorry, I cannot move on my screen.
Otherwise, Elmira, if you could step in and launch.
So what should I do?
Так, хорошо. Секундочку.
You either can relaunch your site, Alexei, or Elmira can launch on your behalf.
Я включаю слайды на английском языке.
Да.
На английском языке. Окей. So now full screen. Full screen, right? Now do you see
Alexei,
first slide with the title and now pipeline of TB diagnostics WHO guidelines, right?
Yes, we see it.
Oh, okay.
Я сделала. Видно или я должна переключить
Эльмира,
канал?
вы можете остановить.
Ага.
Показывает сам.
So this slide, Alexander, if this what I will speak will be different from what is shown, you please will let me know. This slide presents comparison of different sequencing approaches as a background to the WHO recommendations. What is important difference? There are several approaches to sequencing, and until now, most frequently there was used a specific PCR approach, which is not technically sequencing even, but using predefined primer for detection of abnormalities in certain part of DNA. And these abnormalities, for this to work, it needs to be known that this abnormalities is associated with resistance. Until now, most technologies, or all even I can say WHO technologies, were based on this principle. There can be also multiplex, which detects simultaneously several parts of gene, but this all predefined. The technology of sequencing is used broadly in science, sometimes in also clinical management of patients, but technology of whole genome sequences is rather complex and sequences the whole genome, which is more than 4 million base pairs, and this is expensive and complex procedure. Whereas targeted NGS is between these two, we can say between these two approaches, and it can detect, it can sequence totality of particular gene or several genes, which may predict resistance to particular drug. So this is as a background, and sequencing process has several stages, starting from DNA extraction, then DNA fragmentation, following by library preparation, and then amplification of parts of the gene, and sequencing followed by sequencing, and finally concluded by bioinformatic analysis. So if we're talking about targeted genome sequencing, this only includes parts of the gene or gene in entirety, but parts of the genome of Mycobacterium tuberculosis. To summarize, class of targeted NGS products uses massively parallel sequencing to detect resistance to TB drugs. It is started from processed clinical sample, and it is ended with end user report, which relates detected mutation to the presence or absence of resistance. Briefly to summarize process of WHO guideline development, in 2022, WHO has commissioned a series of systematic reviews which evaluated several targeted NGS products which are commercially available. This is important condition. So product, in order to recommend it by WHO, product needs to be commercially available. In other words, everyone who is interested can buy it on open market. Concluding data synthesis and analysis, WHO convened a guideline development group on 2nd, 5th May of 2023 to discuss the findings of the reviews and make recommendations of this technology. Then WHO issued rapid communication, and recently full recommendations were published in March 2024, which is about months ago. Yes. This is third edition of recommendations. There are two main documents. First, recommendations, and second is operational handbook. In order to summarize in few words what means each document, then one can say that WHO recommendation says what to do, and WHO operational handbook says how to do it, which means includes also implementation aspects of particular technology or recommendations. And today we speak of most recent recommendation as it was announced, the sequencing, targeted sequencing. So what are products included in the recommendations? So when recommendation exists, it should be aimed at particular products. So we cannot say in general that method of sequencing is recommended. This is rather test which is recommended. So which means package, which again needs to be available on open market. So 3 products were evaluated. First is Diplex, second is Ampur, and finally TB-Seq. And for the following drugs, for different also drugs, the most broad number of drugs were met criteria and were approved for the first product, Diplex, which is recommended for rifampicin, isoniazid, pyrazinamide, ethambutol, fluoroquinolones, bedaquiline, linezolid, clofazimine, amikacin, and streptomycin. Second product is Ampur, which is recommended for rifampicin, isoniazid, fluoroquinolones, linezolid, amikacin, and streptomycin. And finally, TB-Seq, recommended for ethambutol. I mean, if product is recommended for particular drugs now, which does not mean that recommendations cannot be updated. We already, we have not received, but we know the company is updating their software in case of Oxford Nanopore, which may produce better results for other drugs. So after evaluation and conclusion of technical advisory group, which is transparent also group and process, the recommendations may be updated for particular drugs. and for particular method. What were results shown by different methods for particular drugs? It was considered accurate for isoniazid, levofloxacin, moxifloxacin, pyrazinamide, and tambutol. In general, sensitivity was 95% or above. For bedaquiline, linezolid, clofazimine, amikacin, and pyrazinamide, sensitivity was less. However, it considered acceptable for these drugs, which means that a result which is produced and received quickly can be useful in management of particular patients, but it will depend on prevalence and type of results, and I will focus a little bit later specifically on these details for important drugs as bedaquiline, linezolid, clofazimine, because obviously for these drugs it's mostly needed. Right, for other drugs, there are other methods exist, accurate and sensitive, so it's not so critical. And recommendations. In people with bacteriologically confirmed pulmonary tuberculosis, this technology may be used on respiratory samples to diagnose resistance to rifampicin, isoniazid, fluoroquinolone, pyrazinamide, and ethambutol rather than culture-based phenotypic DST. So in the remarks, it is said that priority should be assigned to those at higher risk of resistance to first-line treatment, including individuals who continue to be smear or culture positive after 2 or more months of treatment, or experienced treatment failure, had previously TB treatment, were in contact with a person with known drug resistance, or reside in settings or belong to subgroups where there is a high probability of resistance to rifampicin, isoniazid, or fluoroquinolones. So there are 2 recommendations, and I would like to highlight, to stress that this recommendation is for people in whom TB was detected but not yet resistance, and for these first-line drugs mostly, but also fluoroquinolones. This method is recommended. And next recommendation is for people with detected tuberculosis, but also rifampicin resistance. For these patients, the method of targeted NGS can be used and recommended to be used for detection of additional resistance to isoniazid, fluoroquinolone, bedaquiline, linezolid, clofazimine, pyrazinamide, ethambutol, amikacin, and streptomycin, rather than culture-based phenotypic DST. Again, remarks say that priority should be given to those at high risk of resistance to medication used for the treatment of rifampicin-resistant TB. I'm trying to move slide, yes. And implementation consideration, first of all, regulatory approval from national regulatory authorities on other relevant bodies is required before implementation of this diagnostic test. In its current format, targeted NGS is high complexity test, most suitable for centralized laboratories equipped with specialized skills and infrastructure. So this is important point that not everywhere, right? And currently, WHO use classification of low complexity, medium complexity, and high complexity, and this is definitely high complexity, maybe even very high complexity. So the center should be equipped, of course, to perform this test. Also, implementation remarks that targeted NGS should not replace existing rapid tests that are more accessible and easier to perform for detecting resistance to rifampicin, isoniazid, and fluoroquinolones. However, if targeted NGS can be performed rapidly, it can be considered as an alternative initial option for prioritized populations. And populations I already have described, those with high risk for resistance, basically. Priority should be given to samples with high bacillary load because samples, when sample has a low bacillary load, which correlates with smear negative or with low semi-quantitative results, low or very low, or trace in case of expert ultra, then recommendation still stands for these samples, but rate of indeterminate results can be higher and was demonstrated to be higher. And finally, or almost finally, I will focus a bit on the implementation for bedaquiline, linezolid, and clofazimine. As I mentioned, the sensitivity is suboptimal, but still these methods were recommended because, first of all, of its rapidity, and also because it is necessary to estimate the pretest probability in the patients in the patient population where this test is used. For example, low pretest probability, when pretest probability is low, pretest probability, in other words, expected prevalence, when test is used in patient population and group of patients where pretest probability is low, a negative predictive value is very good. As you see in the blue circle, in this population, negative predictive value is good. What does it mean in practice for physician, negative predictive value? It means that if result is negative, physician can believe really it is negative, it is truly negative. Because you see in a blue circle, there are 963 in total results, 960 plus 3. Of them, 960 are true negative. So more than 99% of results, negative results, are true negative. Further on, what does it mean for physician? If negative resistance is negative result is obtained and a patient is in front of him, then this patient does not have resistance to bedaquiline and possibly a new regimen can be used for this patient because we can really trust negative results. However, positive results at low prevalence is not that great, right? Number of false positive will be even higher than number of true positive. However, when the pretest probability increase, here is given 5%, it can be even higher. Then number of true positive results is increased, so starts at already at 5%. It is more than true positive, more than false positive. And if resistance or pretest probability will be increased, then further more than 5%, 7% or 10%, this proportion of true positive will be even higher. And then also a physician can believe positive results and exclude these patients from the treatment. But as such, even negative result is very important. So we know that, as I mentioned already, a patient can start on a new regimen. And finally, this is example of algorithm, also updated algorithm from implementation handbook. But there are two algorithms for follow-on resistance, 3A and 3B. And this 3A also only includes targeted NGS, this new method, because it says where available. Clearly, it's not everywhere available. And if not, then another algorithm, including other technologies, like a low complexity test for detection resistance to Yes, and I will not focus on other algorithm and more details in operational handbook. In conclusion, I will say, I will conclude that new recommendation on targeted NGS marks a major shift in the diagnosis of drug resistance TB. It addresses important gaps in the diagnosis of new and repurposed drugs, despite the less optimal performance. The cost and feasibility are potential barriers, but often offer important opportunities post-COVID, meaning that sequencers are more widely available after COVID than before. The best implementation approach is yet to be defined, but will likely to be context-dependent. More evidence is needed on the new drugs and the impact of targeted NGS on patient-important outcomes. And I express acknowledge my colleagues, Zir Ismail, Erkan Michael, and also experts who contributed to current guidelines. And I thank you, all of you, for attention, and will be happy to try to answer questions. Over from my side. Thank you.
Большое спасибо, Алексей, за интересную презентацию. Очень много, я думаю, будет много вопросов. Дорогие коллеги, я призываю всех писать свои вопросы в чате. Алексей постарается ответить на них в письменном виде, в чате, если у нас...
Thank you very much, Alexei, for a very interesting presentation. I'm sure there will be a lot of questions to you. Dear colleagues, I kindly ask you to share your questions in chat, and Alexei will try to answer those questions in writing. And if we have any time left at the end of the webinar, we will review your questions and we'll try to discuss all of them. And now I would like to give the floor to our next speaker, Gulmira Kalmambetova, who is the head of the National Reference Laboratory in Kyrgyzstan of the National TB Control Program, who will share the outcomes of the use of this technology in the country.
So the slides are available both in Russian and English. Gulmira, you can start. Gulmira, your mic is muted. Dear colleagues, good day. Thank you very much for this opportunity to share the experience of my country in the area of implementation of target sequencing of the genome of MTB. And please let me start. Next slide. So speaking about the country, Kyrgyzstan is a Central Asian country. It's a former USSR country. The population is more than 7 million people. 94% of the territory are mountains, and It is separated by mountains into two parts, which also has some impact on the transportation system, but nevertheless, the system is established and it is funded by the state. Kyrgyzstan is also one of the 30 high drug-resistant TB burden countries, and in 2023, 805 cases of multi-drug resistant TB were detected out of the total number of cases, and the total number of cases more than 6,000. Speaking about the distribution of drug resistance upon new and retreatment cases, then MDR-TB rate is 26 among new and 55% among previously treated individuals. A few words about the lab network, which performs TB diagnosis in the country. We have 30 gene expert devices and 2 TrueNAT. TrueNATs have been delivered quite recently and they are being installed, but we are starting working on TrueNATs. We have 6 culture labs and 1 DST lab, which performs phenotypic drug susceptibility testing to 14 drugs, including novel and repurposed drugs. We also perform Hein tests to first and second line drugs, and we are piloting programmatic use of targeted sequencing in the country. And a few words about the transportation system. I would repeat, but it's important. Transportation system covers the entire country. From districts, samples are sent to the National Reference Laboratory for testing and for detection. Speaking about the implementation of the next generation sequencing, I would like to split my presentation into 3 parts, or conditionally 3 parts. Part 1 will be dedicated to the implementation of whole genome sequencing. Second part will be dedicated to targeted sequencing implementation. And the final part of my presentation, just a few slides, will be on programmatic rollout of this technology for the diagnosis of drug-resistant form of tuberculosis. Speaking about whole genome sequencing, the work started in 2017 within a project Stop TB Transmission in Hospitals. The project was funded by USAID. 8 working packages were implemented within the projects quite successfully. The duration of project was 24 months, from 2017 to July 2019. Next slide, please. I would like to, using this opportunity, I would like to acknowledge the contribution of our partners with whose support we were able to implement whole genome sequencing at the level of the National Reference Laboratory. As I've said, the project was funded by the USAID, and it was implemented through the country office of USAID and through Defeat TB project in the country. Our partners included Supranational Reference Laboratory in Göttingen, Research Center in Germany. We worked with Stefan Neymann's team, and they supported us immensely. KNCV, Challenge TB project, also provided their system, and we were the implementing partner. We still continue publishing data, the outcome data on whole genome sequencing, but one of the first articles was the one you see, you can find on the internet, implementation of whole genome sequencing for tuberculosis diagnosis in a low or even below middle income and high MTB burden country. In the article, there is information which might be of interest to those of you who are thinking about implementing a next generation sequencing. You'll find information. It is as of 2017, 2018, but nevertheless, you will see the list of equipment procured. You will see the total amount, total cost. You'll see the list of reagents and also the versions of test systems. What kind of trainings were delivered within the implementation of the Stop TTH project. You will find the entirety of details, and I'm sure it will be really useful to all of you. Next slide. We are always asked within the country, our partners keep asking us, what was the cost? What is the cost of sequencing? Whether it is cost effective to use sequencing for TB detection, whether it will be cost effective to replace conventional methods of TB diagnosis with sequencing, including using sequencing for drug susceptibility testing. The same article contains some information about the costs per sequence, or rather, what was the cost per sequencing of one sample by the end of the project. At that moment, it varied from $141 to $167. But dear colleagues, I would like to inform you that the prices have changed. Insurance costs have changed. The same customs costs changed, and the prices even changed. And therefore, the cost per sample sequencing have changed. But technologies have moved forward. There are new developments, and all the manufacturers are working on reducing the cost of their products. And therefore, it will be interesting to learn from the countries with current experience to use current information. It might be used as a basis for the case of introducing, or in favor of introducing sequencing. The cost per sequence is important, but the key question to answer is the cost of life, of a patient's life. If we can get the result of the targeted sequencing in 3, maximum 7 days instead of 30 days or even longer, then it's not an economical question, it's an ethical question. This is part 2 of our story of introducing next generation sequencing. Now we come to targeted sequencing. It's a logical continuation of a whole genome sequencing with support from the German government, with support of our partners in Borstel and Gauting. We introduced whole genome sequencing in our lab from 2019 to 2022. The goals of the study you see listed here: implementation of the targeted sequencing in a low-income country. And one of the goals of the study was to establish a collaboration, effective, fruitful collaboration between the lab and the clinicians, so that the results of targeted sequencing are used for clinical work. And here you also see the algorithm. I won't dive into the details of this algorithm. The only thing I would like to say that at that point of time, and currently we used GeneXpert result, we use information on the CT value of the device to start targeted sequencing. Next slide. Here you see the results of the SEC MDR-TB-Net project. And I can say that 389 patients were enrolled. We received informed consent from all the patients. 60% were male, 152 were females, and the age varied from 18 to 89 years old. It was a very interesting case. It was a patient, a male, an old man who also provided his informed consent, and he was glad to be part of this huge and important project. 330 samples yielded positive culture results. Of them, 252 had sufficient amount for library preparation, and quality was also good of the library for sequencing. And 235 samples were sent to Borstel for the analysis and whole genome sequencing to assess associations between phenotypic and genetic results. The next slide, please. Of course, we faced certain challenges during the implementation of the project. Those challenges were quite often related to, or the majority of them were related to the COVID-19 pandemic. Unfortunately, the pandemic introduced certain changes. We had a long 9-month long stock out. We also had multiple interruptions of deliveries of the consumables. You all remember that all the transportation systems were stopped, and communication was at suboptimal level. We also had issues with the local distributor. In 2022, because of a very strenuous political situation in Eastern Europe, and sanctions were introduced, and those sanctions and the overall political situation also had negative impact on our work on the introduction of next generation sequencing. We couldn't communicate with our counterparts. We couldn't receive reagents from Albergen, which was based in Russia. But luckily for us, all the issues have been solved, and an office was moved to Germany, and that significantly improved our life. They also helped us with the equipment. They provided the reagents, and we resumed sequencing. Elmira, next slide, please. Taking into account the fact that in 2023, the World Health Organization recommended using targeted NGS as a routine diagnostic method for the diagnosis of tuberculosis, we, in December 2023, introduced it into diagnostic algorithm. Here you see them circled in red, targeted sequencing and whole genome sequencing, and national clinical guidelines have been updated accordingly. And at present, we are developing guidelines for drug-susceptible tuberculosis, and this technology will be also listed as part of the diagnostic algorithm. Next slide. Now, part 3 of my presentation, with the support of the TB project funded by the USAID, we procured all the reagents and consumables, and after a long pause, we decided to pilot programmatic use of this technology, and we requested technical assistance from our partners. And based on the results of the bidding process, we selected international experts, and Andrea Gabibi and Paolo Miota visited the country. They assessed the readiness of our lab to resume the work and provide results to the clinicians. They also assessed the overall workflow. They delivered training for the clinicians on the updated catalog of mutations drafted by the World Health Organization, and they also performed a comprehensive assessment of all the aspects, including transportation system of the laboratory network, so that in future they could give the conclusion on the readiness of our laboratory services to perform surveillance. And I would like to use the opportunity to thank our partners and our colleagues from Milan. Here you see two algorithms suggested by our colleagues from Italy. One is for the intermediate period, when we piloted use of targeted sequencing, and for the transition period, we plan to perform up to 500 targeted sequencing sequences, and it is algorithm number 1. And when we switch to programmatic use, when the pilot period has stopped, we'll test about 900 GeneX positive RIF-resistant strains. And we'll also take RIF-susceptible samples by GeneXpert, because in our country, the prevalence of isoniazid-resistant forms is high. And therefore, we plan to take about 600 isoniazid-resistant strains for targeted sequencing. At present, we perform from 1 to 2 rounds of sequencing per week. We have about 13 samples per run, including controls. A diagnostic algorithm is depicted here. I won't go into details, as our colleagues from WHO Europe and Elmira, all the colleagues have shared the link with all the presentations, and you can read at your free time. So what is happening at the moment? An action plan has been prepared. Now it is being discussed at the national level, and with our partners, we perform systematic discussions on targeted sequencing. We discuss the results of each run. We perform cross checks of the results, which are filled into the forms, which was offered by our colleagues from Italy. And uncharacterized mutations, indeterminate mutations, which might be also a sign of resistance. We pay special attention to novel drugs and repurposed drugs alongside first and second conventional drugs. We try to evaluate the quality of phenotypic DSTs because we need to recheck. We always compare genotypic results with the phenotypic DSTs results. We discuss the findings with our colleagues. For every drug tested, we also discuss the targets selected for targeted sequencing and the genes which can confer drug resistance. We also perform troubleshooting. If necessary, we try sequencing a new sample. We wait for the results of phenotypic DST. We repeat, we compare with hind test results, and so on and so forth. All these will help build organizational capacity alongside with individual capacity of people who perform targeted NGS in the lab. And in the nearest future, I'm sorry, I would like to mention that we closely collaborate with our clinicians, and there is a result interpretation group. We perform regular calls, and we invite our USAID colleagues and clinicians so that there is a well-established communication between the lab side and clinicians with a shared language. Thank you very much, dear colleagues, for your attention. Elmira, thank you very much for the invitation. Gulmira, thank you very much for such an interesting, useful information. I congratulate the National TB Program of Kyrgyzstan and all the partners on all the achievements. You are one of the first to introduce sequencing. There might be questions, I'm sure, to you. Dear colleagues, please put your questions in the chat. Add to that, I would like to introduce our next and final speaker for today, Dr. Claudio Közer, who represents Cambridge University. Unfortunately, because of some personal reasons, he can't be here today. We have an audio recording of Dr. Közer. He will present the results of the survey of the DST capacity in 11 countries of Central Asia and Eastern Europe. But here we have especially from WHO Office for Europe, who will be able to answer any questions you might have in regards to this presentation. Alexander, please start the recording.
My name is Claudio Közer. I'm a visiting scientist at the University of Cambridge. I'd like to start by apologizing for not being able to give this presentation to you live. I had a prior commitment that I simply couldn't move. Should at the end there be any questions that those on the call can't answer for you, please don't hesitate to send me an email. You can find my email address here on this slide, and I'll also include it again at the end of my presentation. Without further ado, it's my pleasure to give an overview of the preliminary results of a survey on genotypic and phenotypic DST capacity that the WHO European region has been conducting, and specifically I will cover the results from 11 Eastern European and Central Asian countries. Before I cover those results, I'd just like to draw your attention or remind you of the fact that WHO has recently updated its consolidated guidelines on diagnostics, namely Module 3, which also resulted in an updated operational handbook, which has several online appendices. These documents include a lot of useful information, particularly the DST manual, which is Annex C. I should point out that there are a couple of errors in these documents that are in the process of being corrected. And over the next two slides, I'll discuss 2 points, one from the operational handbook and one from the Annex C. But I really encourage you to read through these documents carefully, because these cover the newly endorsed target next generation sequencing assays and have a lot of other important updates. The first point I'd like to just mention is that WHO has now set a breakpoint for cycloserine DST using MJIT at 16 milligrams per liter, and moreover, it's now set the first breakpoints for protonamide, again for MJIT, and it has set 2 breakpoints. If you have an MIC of 0.5 or below, then an isolate would be considered susceptible. If an isolate has an MIC of 1 or 2 in MJIT, it would still be considered susceptible, but there's some uncertainty about the treatment outcomes for these strains. So this mainly affects really lineage 1 strains, but these are exceptionally rare in Eastern Europe. So this won't be a big problem, whereas isolates that have MIC of greater 2 would be considered resistant to protonamide. In addition, WHO has selected control strains for key second-line drugs such as fluoroquinolone, bedaquiline, and linezolid. These can be ordered from BCCM ITM, and I would encourage you to do so as soon as possible if you don't already have control strains with well-characterized resistance mechanisms. Now, these strains have been specifically selected to have high-level resistance mechanisms to ensure that they test reliably resistant at the breakpoint. The only exception is likely clofazimine, because there simply isn't any resistance mechanism that confers sufficiently large MIC increases for strains to always test resistant. And in addition, testing for clofazimine is challenging technically, so even this particular control strain is unlikely to be perfect. I'd also like to point out that the control strain for delaminate is also cross-resistant to protonamide, so a single strain can be used for both drugs, and this is due to a premature stop codon in DDN. Availability of drugs, I know, has been a challenge for some of you, and bedaquiline, delaminate, and protonamide can now be ordered through BEI resources. I've included the order numbers here. I'd also just like to remind all of you that delaminate is photosensitive. In other words, you have to protect it from light because it breaks down in light, and therefore, if it breaks down, it'll be less active, and therefore there's a danger of false resistance results if it's not stored correctly. Now, I'd just like to spend a slide to really cover the methodology of the survey. Now, we sent an online questionnaire that was sent to the officially selected representatives of all countries or regions, in addition to the WHO supranational reference laboratories and national centers of excellence. In other words, for some countries, we would have received multiple results. So, for example, from Russia or Germany, would have received multiple results. And this is really important because sending questionnaires like this to clinicians might give an incorrect picture of the capacity if clinicians aren't aware of the full testing capacity within a country. So doing this in this structured way is really important to get an accurate or an as accurate picture as possible. Now, the main focus of this questionnaire was really beta-actin, protonamide, and moxifloxacin and antiproquinolines, simply because of the importance of the new regimen. So this was really the driver for this questionnaire, but we've included every single drug, including carbapenems. Excluding carbapenems, because for those, phenotypic drug availability isn't possible at the moment at all with any method that has been thoroughly investigated. In addition, we covered all commercial genotypic DST assays, irrespective of whether they are WHO recommended or not. This is really because we wanted to get a comprehensive picture of what's happening across the region. And specifically, we asked whether at least one laboratory in the country is testing for a particular drug or is using a particular assay for routine patient care, or alternatively is in the process of validating it if it's not already being used in at least one laboratory. Now, this means that some assays or drugs are only tested at the reference laboratory level, and it might mean that some countries within, some laboratories within the country are in the process of validating an assay, but if it's already being used in at least one laboratory, it would be counted as being in routine use already. And to be clear, for some drugs such as protonamide or bedaquiline, we do not believe that every single laboratory in a country should be testing this particular drug, because establishing capacity for testing and maintaining proficiency is challenging, particularly if a particular laboratory only encounters isolates that require testing very rarely. So for some assays or tests, the best location for testing really is the national reference laboratory or a center of excellence. I should note a couple of limitations. Because we sent this questionnaire to typically one or two people within a country based on the criteria that I sent to you earlier, this might give an incomplete picture, particularly of the testing capacity using some genotypic DST assays. And this mostly applies to Western European countries where testing can be highly decentralized. A good example of that would be Germany, where individual laboratories can decide which tests to establish. So there might be an incomplete picture there. We also didn't explicitly ask to which standard an assay was validated. We simply asked whether it was being used for routine care. We also didn't ask to what extent internal external quality assessment was already being carried out. And of course, these are important questions even for laboratory developed tests, which really most phenotypic tests fall under, particularly in light of the IVDR regulations in the European Union. Now, I'm going to be focusing on the preliminary results from the following 11 Eastern European, Central Asian countries that are supported by the Global Fund. But I should note three exceptions. We had to exclude the results from one country because we are waiting for some clarifications. And we also had to exclude the genotypic DST results from two countries again because we're waiting for clarifications to the answers that we have received to date. Now, this slide summarizes in an anonymized and aggregated way the phenotypic DST capacity. And the important point here is that every single country has phenotypic DST capacity to detect MDR, pre-XDR, and XDR TB, and all countries also test clofazimine and delaminate. And this is really important and welcome news. Cycloserine is only being tested by a single country, and this was really because WHO didn't recommend testing to date, but now with the critical concentration for cycloserine, I do think that establishing capacity is important. We all know that cycloserine will be used rarely because it's been downgraded, but for challenging clinical cases, it will be required. Not all countries test for amikacin. This is to some extent understandable because obviously there is genotypic testing capacity, and also the use of amikacin has been much reduced. But again, I think that for challenging case of highly drug-resistant TB, amikacin will be required, and therefore having capacity for testing is important. Streptomycin isn't being tested by any country, and this is due to the fact that the resistance rates to this drug are very high amongst MDR, pre-XDR, and XDR cases. Ethionamide and prothionamide test is only being tested in 4 laboratories, and this again is because of the high rates of drug resistance, and obviously there's also some capacity, genotypic testing capacity. Para-aminosalicylic acid is not currently recommended for phenotypic testing by WHO, and only a single country is testing it. And when it comes to protonamide, 2 countries are already testing it, and 3 countries are in the process of validating testing. But I should point out that several countries from this region and the wider region have really noted that there was confusion about how results should be interpreted. So sometimes countries only determine the MIC, but don't interpret that result. But also there was a lot of confusion about how these results should be interpreted, because the recommendation by UCAST aren't aligned with the recommendation by the packaging insert by the European Medicines Agency. And then in addition to that, the recently published breakpoints that I mentioned earlier by WHO aren't in agreement with either of these 2 recommendations, which will cause difficulties, particularly in the European Union, but also other countries outside of the regions that follow UCAST guidelines. So this is an area where really more alignment is required to minimize confusion and also minimize the amount of concentrations that need to be tested. When it comes to genotypic DST capacities, all countries were either using the traditional version of the Cepheid MTB RIF, or using Ultra, or the more recent XDR cartridge as examples of low complexity automated molecular assays. One country had already adopted the more bio-TrueNet assay, and obviously this is a more recent development, and the second country was in the process of validating that assay. One country was already using a moderate complexity assay, namely the fluorotype. In addition, obviously, there is a legacy of the LPAs for first-line and second-line testing. And when it comes to target next generation sequencing, which was recently endorsed by WHO, and again, you can find much more information about the precise endorsement, about when phenotypic testing is still needed if you use target next generation sequencing in the guideline documents and the operational handbook that I mentioned at the beginning of the presentation. But one country is using the GenoScreen assay, the second country is using the Oxford Nanopore assay, and 2 more countries in the process of validating the Oxford Nanopore assay. And last but not least, one country is in the process of validating whole genome sequencing. Thank you very much for your attention. If you have any questions, I'm sure that many, if not all of those questions can be answered by other people who are on the call today. And should you have any questions left, or should you have any other questions that after the presentation?
Thank you very much, dear colleagues. We have just heard the presentation of Dr. Közer. Should you have any questions related to this presentation, we have our colleague from the WHO Europe who can answer these questions. We have about 20 minutes left that can be dedicated to questions and answers. We already have a number of questions ready, and I'm ready to read it. The question is for Gulmira. Question from Dr. Volchenkov. Do you plan to use the results of the target sequencing for detection of transmission of drug-resistant tuberculosis and for monitoring the risk of intra-hospital infections? Thank you very much for your interest and thank you for your question. Indeed, we do perform the epidemiological studies, including those focused on nosocomial infections, but at present we are more focused on targeted sequencing. And in the long-term perspective, we plan to implement the epidemiological surveys, including those focused on nosocomial infections. Thank you very much, Grigory. Thank you very much, Gulmira. I continue with the questions. And now I would like to ask the question to Alexei. You have noted that the sensitivity of targeted sequencing for detection of resistance to linezolid, clofazimine, and bedaquiline is at the level of 70%, 68 and 69. But this is the general sensitivity. Is it just as true as for positive specimens with high bacillary load? And can we expect a higher resistance for that? No, this is just the average percentage. We did not perform any stratification for the low bacillary load and high bacillary load. And again, we need to have certain thresholds for that. It would be possible to perform this kind of analysis in the framework of the research project, but within the recommendations, we have the same recommendation for the specimens with high and low bacillary load. So one can expect that the frequency of undetermined results would be higher in cases of lower bacillary load. So preferably we need to opt for high bacillary load. And if you have low bacillary load, then you need to test the second specimen and repeat the result.
One more question. Dr. Közer in his presentation mentioned that WHO has provided critical concentration for cycloserine and pretomanid, and he also mentioned cross-resistance between pretomanid and delamanid. How high it is? Can it, in the case with injectable drugs, having result to one drug, can we say that there is resistance to another drug as well? Or is this cross resistance a bit different, incomplete? So how would you comment on that? Thank you. Elmira? There is data on cross resistance because some genetic markers are common for these drugs, and the mechanism of action is the same. But as far as I know, it is not complete resistance. Official level health organization hasn't made any official statement. As far as I know, it is not incomplete. So we cannot say that there is complete cross resistance. Therefore, I would approach the results with some caution. Thank you very much. Are there any more questions? There are no questions in the chat. I see that colleagues from Kyrgyzstan and Belarus in the chat have shared important contact information, and I'm very glad that our webinar served a platform to solve some technical issues as well. It's a pity that Belarus faced some issues with supplies. As far as I know, with support of NSF sequencing was being introduced there. Dear colleagues, if there are questions, please don't hesitate to ask them. Raise your hands. If there are no questions, then we fit into the time allocated to the webinar. I would like to pass the mic to Dr. Yedilbayev to say some final words. But before that, I would like to thank once again all the speakers for very important novel information which we need to think on. Thank you, Elmira, dear experts. Thank you very much for coming here and sharing knowledge on this important area. And this knowledge will be used first for joint work, for collaboration, and to also strengthen technical assistance provided by WHO Office for Europe. And at the end of the webinar, I would like to say that our next webinar will be announced. It will be announced in the nearest future. I hope that the topic of the next webinar will be also interesting. And I would like to reaffirm that the work of our Virtual Medical Consilium is continuous. Present your cases, ask for opinion. We looking forward to further collaboration. Today, we had more than 160 visitors, attendees, and it's a very, very good participation rate. I think everyone who participated, and wish you all the best. All the best, dear colleagues. See you at the